Good morning. I am Visalakshi, Assistant Professor, Department of Electrical and Electronics Engineering in Thandai Periyar Government Institute of Technology, Vellore. Welcome to e-learning class, and today's topic from Power System Analysis, Unit 2, Introduction. So these are the contents we are going to see: bus classifications, formulations of power problem in polar coordinates, power flow using Gauss Seidel, and voltage controlled bus, and power flow solution by Newton-Raphson method. And here in basic introduction for load flow study, which involves the solution of power system network under steady state condition, and its main considering constraints imposed on node voltage, reactive power of generators, and it is main important in planning and designing the expansion of power systems, magnitude, phase angle of voltage, real and reactive power, and line losses, which is obtained from the load flow analysis, and it is required for deciding the operation of power system. So the main information from the load flow are which gives the initial condition when the transient behavior of the system is studied, and it is mainly essential to decide the best operation of existing system and designing new power systems. In load flow study, general requirements are given. One is representing the system by single line diagram, determining the impedance, formulation of network equation, and solution of network equations. So these are the some requirements to follow the steps. So some of the classifications of buses are, so bus type, slack bus, swing bus, generator or PV bus, load or PQ bus, voltage control bus. So these are specified by the variables V, del, P suffix G, magnitude of V, and unspecified variables are P suffix G, generator, and these are the remarks means the quantities to be obtained. So here in the classifications of buses, generator will feed energy to bus and load will draw energy from buses. Here it becomes node and voltage can be specified for each buses. So it is represented with the four quantities: real power, reactive power, and magnitude of voltage and phase angle of voltage, which we saw in previous slide. And here two different quantities are specified in each buses, and the remaining are to be obtained by solving the load flow equations. So these are the specified variables, and these are unspecified variables, and here these are the quantities to be obtained. So for example, for generator bus, Q and del are the quantities to be obtained, and the generator is present at the machine buses. So these are some of the classifications. And here load bus means when real and reactive power are specified. The load flow quantities can be solved to find magnitude and phase of the voltage, and it is allowed to vary within the limit for example plus or minus 5%. And for slack bus, important is slack bus. If the magnitude and phase of the voltage are specified, okay, the slack bus is called a reference for load flow solution, and usually one of the generator buses selected as a slack bus. So mainly what is the need of slack bus? So here basically two types. and they are load and generator bus. Here, generator and power can be drawn by the load which is specified. But in power system, power generated will be equal to the power consumed by load and losses. Okay, so the real and reactive power of the generator bus is not specified and it is called as a slack bus. Okay, so some of the importance, so these are the importance of swing or slack buses. Okay, so here main important for slack bus will be, so as I told already, both the magnitude and phase voltage are specified at the swing bus or assumed to be value 1 per unit and 0 degree. Okay, and both real and reactive power at the slack bus are found by the part of load flow solution, and it is to be noted that the source at the swing buses are perfect, and that's why it is called a swing bus, swing machine or slack bus. So some of the effects of uh, acceleration factor in load flow study using Gauss Seidel mainly to increase the rate of convergence. And similarly for a generator bus, there is a specified limit, then the generator is treated as a load bus if the reactive power constraints. And next is your load flow. How to find the load flow problem. Okay, so here from the block diagram, the power systems is a large internet system where various buses are connected by the transmission lines. So at any bus, complex power is injected, okay, by a generator and drawn by the load. So P plus JQ. So these are the complex power, both real and reactive power with a load. Okay. So here from one bus to other bus, the transmission line is transported. So for example, at any bus means I, the complex power will be SI. So SI will be equal to PI plus JQI, means generator. Okay, so what it represents? S suffix I represents complex power injected to bus I. SGI represents generator and SDI represents the power drawn by the load at bus I. So these are the load flow problem to calculate. So these are, and how to calculate. For example, there is a complex power means S equal to P plus J QI, and this will be equal to sum of the complex power. So as I told that the power system will be equal to sum of the complex power of generator equal to power of the load plus total power loss in transmission line. Okay, so here I will be specified as the sum of all lines connected to the bus. N represents number of buses in the system but excluding the ground. Okay, so it can be represented, I bus means current drawn by the load will be represented with a frame I bus. Okay, I suffix bus will be equal to Y bus into V bus. So it can be represented in a matrix form I1, I2 up to In, and similarly V1, V2, Vn. So Y bus represents bus admittance matrix. And here these are the formulas to calculate the current, means summation of J equal to 1 to N bus admittance Ij into Vj. Okay, so value varies from 1 to N. And similarly, after finding current, we have to find the complex power V into I. Okay, here I represents, so this equation will be represented here. Okay, summation I equal to 1 to n y I j v suffix j, and here vi into summation of j equal to 1 to n y I j into vj. Okay, so here it represents same. Okay, here the representation. So here this is the formula to calculate the complex power SI. Okay, so here to find the admittance matrix, we have to find G plus JB. Okay, so susceptance plus B. Okay, so here we have to substitute all the values in complex power. So we can obtain for SI will be summation of J equal to 1 to n Vi Vj of complex power. So cos del plus j sine. Okay, y, right? So for Yij, G minus JBI. So by separating the real and imaginary part from the above equation, so means P plus J Qi, right? So here what we have to do is just multiplying with the G and representation of B, and then we are going to split the real and imaginary part. Here from the given equation, 1 is my real and 2 is my imaginary part. Okay, so summation j equal to 1 to n vi vj. So when I am multiplying G cos del ij plus bij sin ij. Okay, similarly the main representation is plus and minus. Okay, so there is an alternating representation for y, that is admittance in polar form. So both rectangle and polar form is represented. So here in terms of angle. So in terms of angle means 0 degree. In terms of real part, the value of per unit will be 1. Okay, so after representing both in rectangle form and polar form, we have just represented the complex power in polar form. So this equation represents my polar form. Okay, and here, so this is what the real part and imaginary part. So from the given slide, we have separated the equation, above equation, that is Pi, right? So I'm just taking the V suffix I bus outside, and then we have find the Yij magnitude of Vj cos of just a common terms, and similarly for the values. Okay, so means I varies from 1 to up to n, and similarly for imaginary part of the equation, same, only difference will be cos and sine and the value. Okay, and this is your equation number 4. So from the equation 1, 2 and 3 and 4 are the equation of power flow equation or load flow equation to calculate. Both are same an alternative equation which is corresponding to the n bus systems. Okay, so in here just a overall view. So here we have discussed the load flow study introduction and different types of buses, and how to calculate the power flow equation or load flow equation, both in terms of rectangle part and polar form, rectangle form and polar form. Thank you.